The modern dog population is staggering in its diversity. We share our homes with animals ranging from 5-pound toy breeds to 200-pound giants, all categorized as the same species. They fulfill a massive array of roles, competing in high-speed agility trials, working as service animals, or simply living as household companions. But if you look back between 15,000 and 40,000 years to the late Pleistocene, this entire domestic population vanishes from the fossil record. In their place was the gray wolf. During this era, the wolf was an apex predator and a direct competitor for the same high-protein resources that early humans needed to survive. This raises a difficult question. How did a dangerous rival become our first domesticated partner, long before we had even invented agriculture? Biologists point to the commensal pathway. Wolves initiated contact by scavenging at human camps. Less fearful wolves gained a steady calorie supply, and over generations bred only with one another, permanently splitting from their wild ancestors. We see the result of this process 14,000 years ago in a burial site in Bonn, Oberkassel. Excavators found the remains of a puppy buried in the same grave as a man and a woman. Forensic study of the puppy's teeth showed it had survived a severe case of canine distemper. Because the animal was too young to work, its survival suggests it received weeks of intensive care from the humans it lived with. The Bonn Oberkassel find provides a window into this emerging bond, showing an animal that had moved from being a scavenger on the perimeter to a protected member of the social group. This new lifestyle led to significant biological changes. Unlike wolves, dogs evolved the ability to thrive on a starch-rich diet, allowing them to share the same food sources as humans. While their diet changed, their predatory senses remained sharp. Dogs can detect odors at concentrations 1,000,000 times lower than humans can perceive. Their hearing is equally specialized, allowing them to pick up high-frequency sounds from 4 times the distance of a human ear. They retained ancestral features too useful to lose, like 42 powerful teeth, thick nails for digging, and panting to stay cool. Once the bond was established, humans realized these predatory traits could be refined through selective breeding to perform specific tasks. We engineered earth dogs to be small and persistent, using their thick nails to pursue prey deep into underground burrows. Sighthounds were bred for pure speed, stretching their biology to the absolute limit to hunt by sight across wide-open plains. In herding breeds, we hijacked the wolf's natural stalking instinct. Instead of completing the kill, they use that predatory focus to move and protect livestock. By taking the existing blueprint of an apex predator and selecting for specific traits, humanity created a living tool for almost every survival challenge. While dogs still hold specialized jobs in the field, most have returned to that earliest role established thousands of years ago, the loyal companion. Their lives operate on an accelerated schedule. 1 dog year equates to roughly 4 to 6 human years, meaning their entire life cycle is compressed compared to ours. Although an individual dog's life is short, the species has maintained a constant presence in human culture for over 14,000 years. They hold the unique status of being the very first species humanity ever domesticated, predating horses, cattle, and cats. By serving as our earliest mobile alarm systems and hunting partners, dogs provided the security and resources that helped our ancestors expand and thrive across the globe. A wolf moves through a dense forest by calculating every obstacle independently. In a complex environment, like an agility course, a domestic dog navigates by constantly glancing back at its handler. We traditionally view the 25,000-year history of canine domestication as a selection for tameness and physical changes, like shorter snouts, smaller teeth, and a reduced cranial capacity. This focus on physical traits overlooks a structural alteration in the canine's cognitive architecture. For decades, researchers evaluated canine intelligence through the lens of interspecific dominance, the assumption that dogs organize their social interactions through a rigid hierarchy. This dominance framework relies on standard operant conditioning. It treats the human as a pack leader who secures compliance through a system of rewards and punishments. The dominance model fails to explain canine behavior in complex problem-solving scenarios, where dogs actively seek information from humans. Accurate mapping of canine information processing requires abandoning the ancestral wolf model in favor of frameworks used in human developmental psychology. The dog-human dyad functions as a specialized attachment bond, replacing the ancestral pressure for social submission. This bond mirrors the dynamics between a human infant and a caregiver, establishing canine curiosity as a socially dependent mechanism. In the unsolvable task paradigm, both subjects face identical locked puzzle boxes. The wolf exhibits relentless physical persistence, exhausting every angle. The dog, however, quickly ceases physical interaction, instead establishing a direct line of gaze with the human. Handlers frequently misinterpret this redirect as a lack of intrinsic motivation, or simply giving up. This behavioral shift represents a highly evolved cognitive strategy, known in literature as social scavenging. Social scavenging involves the deliberate solicitation of human assistance to acquire data or resources when the canine faces a novel challenge. Domestication systematically replaced independent physical problem-solving with a biological reliance on human social referencing. The comparative framework for this behavior lies with human infants and current research on developmental cognition. Developmental psychologists define epistemic curiosity as the drive to acquire new knowledge for the sake of learning, separate from the desire for immediate physical reward. This curiosity is driven by metacognition, the cognitive awareness of what an individual does and does not know. Infants resolve gaps in their knowledge by seeking information from a knowledgeable social partner rather than through isolated trial and error. Pre-verbal infants use specific physical cues, such as pointing or directed gaze, to solicit this information. Comparative cognition studies show that dogs utilize this exact same information-seeking gaze when facing uncertainty in their environment. Dogs register when a human's emotional or communicative signals violate their expectations, which prompts further information seeking. Dogs process environmental novelty by actively querying their human counterparts, utilizing the same neurological pathways as a pre-verbal infant. John Bowlby's foundational attachment theory originally classified human caregiver-infant relationships using 4 criteria: proximity seeking, separation distress, safe haven, and secure base. Empirical behavioral data confirms the dog-human bond meets all 4 of these developmental attachment criteria. Under the safe haven criterion, the presence of a familiar human reliably attenuates a dog's physiological stress response to threats. The secure base functions as the psychological foundation from which an individual can safely explore the external environment. This secure base effect dictates a dog's capacity for neophilia, the attraction to novel objects, tasks, or experiences. Dogs are significantly more likely to manipulate novel tasks or exhibit bold exploration when their specific owner is present. Human presence acts as an active regulatory mechanism, meaning canine curiosity is constrained by the strength and security of the dyadic attachment. Human personality is a critical variable in this bond, specifically the Big Five trait of neuroticism. Handlers with high neuroticism scores frequently exhibit excessive signaling and delayed responses during tasks. Data correlates high handler neuroticism with degraded canine performance in operational or working dog contexts. Paradoxically, dogs handled by highly neurotic owners exhibit lower baseline salivary cortisol levels. These dogs often view highly neurotic owners as more socially attractive, leading to stronger proximity-seeking behaviors and deeper attachment. The resulting data creates a tension between operational functionality and affective well-being. Dyadic functionality in a working capacity is not mutually inclusive with a positive, low-stress emotional bond. Methodologies evaluating the human-animal bond, such as the MDORS, MPAWAS, and DAQ scales, have significant limitations. These survey-based tools suffer from anthropocentrism, relying heavily on human self-reporting and subjective perception. These human-biased tools frequently miss the cognitive and physiological reality of the dog's experience. Evaluating dyadic health requires neurobiologically grounded metrics, like fMRI analysis of the canine brain. States of high curiosity and secure attachment trigger dopamine production, which enhances hippocampal functioning and memory retention. When a dog encounters unexpected cues, its ability to learn and adapt is modulated by the specific attachment style and personality of its human handler. The modern dog functions as a cognitive symbiote, relying on its human counterpart for environmental interpretation and stress regulation. Optimizing canine welfare requires abandoning dominionistic viewpoints in favor of understanding this uniquely interdependent neurobiological bond.